Hello, and thank you for joining this webinar, the last in the series on HANA operational best practice. I'm Robin Webster, CTO at Centiq.
Hi, I'm Steve Stringer. I'm a SAP HANA consultant here at Centiq.
So this webinar is about operational best practice. So it's combining some of our architectural know-how and knowledge gained from running HANA systems since 2011. So to start with, we're going to take you through some information about capacity and performance on HANA. So this is something everyone should do, but nearly everybody forgets to do. Now, you probably, if you've got a HANA system, having all of your data in memory might not be an option, or it might not be an option forever. Memory is expensive. So
yeah, I think it's always worth saying that that's the ideal place with a HANA system, that all the data can reside in memory, and that's where you're going to get optimal performance.
Yes. So, it can't go on forever. The systems will grow over time, so you need to have a strategy for what you're going to do when it does start to run out of space. So what you should really do is have a look at your data, the different types of data, the different ages of data in your organization, and decide really what kind of performance you want for each area. So creating a table, something like this, that you can share with the business and get an agreement on, so that when things change further down the line, when you've got capacity challenges, you've got something to refer back to, something you've agreed on. It's going to help you with the design process. It's going to help you with all of your operational processes around capacity and performance from that point forward. You might be surprised as you share with the business your kind of assumptions. You might be in a very different place to them. I think typically IT people want the best performing systems to be in place, but it's not always the case that all requirements are the same, that they all need the same kind of performance.
And when we talk about performance, we often talk about in data that's older. Maybe it's preferable that that's less performant, but there's also functional areas which could be less performant. The performance could be sacrificed for other functional areas.
Absolutely. And of course, it's worth saying as well, once HANA's in place, expectations will change over time because they'll get used to having very, very fast performance. So again, it's worth really recognizing which areas need that performance and which don't. So getting them written down helps.
I think we're going to talk about the tools for those sort of things a little later on.
Yes. But let's talk about how capacity and performance are linked within a HANA system. And here we've got an illustration of how a system might grow over time. So we've got the green line, which illustrates the data footprint as it gradually grows. And we've got the red line that's wiggly just below the green line, which represents the data that's held in memory. And then we've got the dotted line going across horizontal, which shows you where approximately the sort of 50% marker for the memory available to HANA, which is typically the sort of area in which you can drive your in-memory data up to. And so what we've done here is illustrate how when you start a system, when you've got a low level of data in it, and you can fit all of that data in memory, you're optimized for performance. Everything will be running from memory. But as that line goes up and it starts to reach the 50% marker, then you will get a degree of potential for degree of contention for memory, and so performance might start to drop off. But typically, there's a gap between the data volume and the actual amount of memory you need in data. So there's some data that you perhaps never read, dark data in the system. So you probably still optimize for performance. But as that continues to increase, you will reach a point at which I'd call it optimized for cost, in that you have some contention for memory, but the items of data that are being ejected from memory due to other reasons are things that are not being read very frequently. So it doesn't really matter. The performance isn't really hit. You may be having an unload once or twice a week.
So you're still hitting your SLAs for your critical business processes.
Exactly. But you're getting the maximum out of the system, perfectly sized. But the challenge with being perfectly sized is it's very close to being overloaded, which is right at the other extreme. And in these examples, you will have loads of unloading, so lots of unloading, highly frequent unloads, and the data that you're unloading is something that needs to be read in shortly after. So you get loads and unloads happening all the time. So you're then doing lots of data I/O to disk, and your performance will drop off the cliff. If you're in a clustered environment, you can have all sorts of challenges.
And overloaded. I guess we're categorising as that as having a business impact.
Absolutely. Yeah. So your query times are going to have delays. In fact, some things might time out and fail. Yeah. So absolutely, the antithesis of what HANA's about. So you need to really be on top of this capacity measurement and understand where you are and where you're going to be in the future to have a performance system. So we're going to move on now and talk a little bit about sort of common configuration issues.
Yeah, so part of best practice is avoiding these common configuration errors that we see. What we find on newly installed systems is, I mean, there's many things that can be configured badly, but we've picked out a bit of a top 3 to discuss here on the webinar. One of the main things that we see go wrong on HANA systems is the global allocation limit being set incorrectly. So the global allocation limit in HANA is the amount of memory that can be allocated to all the HANA processes combined. Now, by default, there is an algorithm which figures out what HANA thinks that memory limit should be. So if you don't set one, it will take the default setting, which is nearly all the memory in the box. Now, for larger systems, that can often be okay. For smaller systems, I'm thinking systems under 128 gig, then that can be problematic because it doesn't leave enough memory for the operating system and for other, bespoke drivers and other bits of software such as backup tools and monitors.
Yeah, so it could be different in every case, can't it?
It can be. But the problem is that when you apply too much memory to HANA, other things can start to break. The system can swap heavily, and the out of memory killer can come in and have sometimes quite unexpected results. It could kill HANA, it could kill a vital file system driver. It's a situation that you want to avoid completely. So it's really about looking at the available memory, looking what the underlying footprint of the OS and the other bits and pieces are, and allowing HANA to use the rest of it. Also, you get a big problem where you've got multi-SID installed, so you've got 2 or more installations of HANA on the same box. If you leave that as the default setting, you will certainly get a problem. You'll have over-subscribed the box and you'll get serious problems.
Yeah, a common one we see is where you've got a sacrificial DR system, so you've got your primary system replicating to a secondary system, and that secondary system is also used for your pre-prod or test environment. And if you don't balance the gals between those two, it's very easy to oversubscribe the box, isn't it? And that can mean that the system restarts frequently. It happens so frequently that actually, we've tuned our own monitoring system to pick up those oversubscribed settings.
To pick up those configuration errors.
Yeah.
Another very common one is log mode. What we find is the SAP and some SIs do advise log mode to be set to override whilst people are doing large data transfers, which is common when introducing a new system. The problem with log mode is it should always be set to normal unless you've got some very particular use case like a batch insert. Because when you don't have log mode set to normal, you're not creating log backups. That means that your point-in-time recovery functionality disappears completely. Now, the problem with these configuration settings are they're very easy to set. They're sometimes difficult to remember to flip back. So it is a common one where we log onto a system and it's one of the first things that we say, you do know that you can't restore this system correctly. And sometimes customers say, no, I didn't know that.
You'd have to go back to your last full backup rather than a point in time. I guess that's one of the reasons for your big statement at the bottom saying always use HANA Studio or the SQL statements to update the configuration.
Certainly you don't want to be going in and doing things by hand. There are some situations such as system replication where that is the only way to do it, but generally you should always use the correct tools to update the config.
I guess if you edit the file directly, you've not got the same checking, so you could end up with a spelling error or something in the file, and it will be ineffective.
Yeah, or just a malconfiguration, just trying to set something that, like a bool to a numeric value, for example.
Yeah.
And finally, just on the common configuration issues, the base path for the log backup, or the log backup path, it's a setting that gets frequently changed from the default, because you should never set the log backup to the appliance itself.
So this is where you're not using the backend backup to regular backup products.
When the log backup files are going, when the log backups are going down to file, you will want to set the path so it saves to like an NFS location or a separate LUN, over iSCSI or Fibre Channel, something like that. Now, the problem that you can get with this is that you can change the setting, but it does no checking for you. So you can change the setting, but it doesn't check whether the database has got permission to write to that location.
Right.
So if it hasn't, the log area will fill up until the system eventually runs out of log area, and you have to do a very forensic sort of bunch of steps to fix that issue. You have to copy the stuff out and symlink it back.
Of course, it'll stop writing to the database at that point, won't it?
Yeah. You'll be able to query, but you won't be able to change any values.
And I suppose there's, if you're writing to NFS as well, you're going to need to make sure that you're monitoring that NFS location, because it's going to be critical to the running of your production system.
So definitely look out for those ones. So that's just about wrap that up. But we can now look at some of the common optimizations that we perform for customers as well. So one of the first things that we look at in terms of optimizing a system is the workload management. Now, the workload management is really useful because by default, HANA gives every single statement that it gets the same priority. It allows all the statements to be sharded across all the CPUs. So everything always gets maximum performance, which smaller systems or analytic systems, that can be fine, absolutely no problem. When you get larger OLTAP systems, it can start to cause lots of contention. So workload management allows you to limit those resources, like the parallelism, you can limit memory resources, you can limit the CPU resources.
So I guess a really good example of making good use of this would be where you've got mixed analytic and online transaction processing. So if you've got an ECC or S4 system and you're using some of the HANA Live functionality to get analytical views out of your primary database, you might want to restrict that kind of access versus the transactions that are running your business.
Yeah, so operational reporting, really good example, because the operational reports, people running those frequently and digging down onto the row level data, that could slow down the day-to-day OLTAP stuff. That could slow down sales orders or stock movements or things like that. That's a situation you potentially want to avoid. So there's a number of ways you could do it. You could create a workload class which includes all those views, selects on those views, and you could give them a low, limit the amount of CPUs that they can run on, and then the day-to-day business can go ahead whilst slightly slowing down the operational reporting. So that's a really good example. And you can go much further than that. You can prioritize workloads based on the class, the ABAP client, the application name. Right. You can actually go all the way down to the SAP username. So if you've got a particular problem user that does lots and lots of reports and churns up a lot of CPU, you can really trim that down and limit what that one user can do, or a group of users.
Limit the damage to a single person.
Limit the damage limitation. Yeah, that makes quite a nice headline, damage limitation. We should have used that. We've also got SQL plan cache that we use quite often in optimization. Now the SQL plan cache, every time a statement gets entered into HANA, the SQL optimizer has to create a plan. Now that plan gets stored if it can be reused. So if the exact same statement comes in, that same plan can be reused, saving that optimization time.
Right.
Now, when you run the optimization reports against HANA, one of the things it often says is, there's too many evictions, too many old plans are being thrown away, so it's not a good use. So
I guess you can make it bigger.
You can make it bigger. That's the first line of attack, or you can do it a little bit smarter. And certainly on some of the native systems that we've optimized, what we've noticed is every single insert creates a plan. And when these inserts are unique, say they've got a date stamp on there, that insert is never going to be repeated. So any insert that you do it's not going to be repeated, you can put a hint into the insert, into the statement, to tell it not to save the plan cache. Right. And when we've done that, we've seen the number of evictions just absolutely come right down. So you're getting much more efficient use of that space that you reserve. I think it's something like 16 gig of memory is reserved for plan caches. Right. So if you can make better use of that, all the better. Now the third bit that we look at quite commonly for optimization is table partitioning. So, and again, this comes in two flavors. Firstly, there are tables sometimes on systems that can benefit from being partitioned. Realistically speaking, anything with more than 500 million records in should be partitioned, and it gives you various advantages. One of the biggest being when you need to, the way that HANA works is you've got a table. When new records are added, it writes those changes to a delta. Then later on, when that delta gets merged into the main bit of the table, it has to decompress the whole thing into memory, and they have to write it back to disk. Now, if you can partition the table in such a way that the amount of the amount of data it needs to uncompress and write back to disk is smaller, then that's a big optimization for the system. The system has to do less work.
Absolutely. So less CPU time, less memory consumption, and less disk I/O, which might not be a challenge for everyone, but if you're doing things like replication, like your disk layer or something like that, you might be concerned about the sort of level of change in the disk subsystem.
Yeah, if it's just a high insert database, if it's the sort of database that sees a lot of records being written all the time, then anything you can change on I/O, any way you can optimize the amount of I/O, the better. But to do that sort of intelligently, you need to be using the range partition. And it's a human that's got to go in and make the decisions. As there's no automatic fix for these things. Another fix that we get for partitioning is quite often the DMO process to migrate a SAP product into HANA sometimes does some dumb partitioning of tables. It doesn't do partitioning intelligently, so it will create a hash partition for a large table that's got a compound key. Now, when you've got a compound key, a primary key made of multiple columns, to create the hash, there's quite a sizable CPU overhead, so it slows down the inserts. So what we've been able to do for some customers is change that to a range partition, which optimizes that merge again that we talked about previously, but it also cuts down the computational time that would be used to make a complex hash.
Yeah, and of course the other advantage of range partitioning with something like date, on the assumption that the newest stuff is going to be updated more frequently or read more frequently, it's going to reside in memory more frequently, and then the older stuff is less likely to reside in memory. So you're sort of widening the gap between the data footprint and the in-memory data. So you're kind of making more efficient use of memory.
Well, that's, as long as all the select statements for that reference the date and not some other field, because then it will need to load them all in. But again, that's about query design. Yeah, okay. So there's some of the main things that we look at in terms of optimizations.
So now we're going to talk a little bit about the scale-out optimization, which is primarily for BW systems. So if you imagine you've got an 8-node BW cluster, as I've got here, it's quite likely that the balance of that system will not be perfect, and especially if it's been running for some time without the rebalancing happening. So why do they get out of balance? Well, let's look at the way that data is distributed across those nodes in the system. Well, to start with, as you create each of the objects within BW, it will create new tables on a round robin basis across the cluster. So and as they grow, they all could grow at different rates, and the growth in itself doesn't trigger redistribution. So you'll end up with differing sizes of objects across the database for that reason. Now, the different objects operate differently within the organization. You get DSOs, which are hash partitioned across, which gives the opportunity, anything that's hash partitioned on the first level, it tends to be distributed across the cluster. So you'll get DSOs that was spread across. Info objects and PSAs, things like that, tend to be single partitions, or at least not partitioned on a hash basis, and they're not distributed across. So you've got two types of objects that are distributed differently. DSOs are partitioned depending on size as well, so they'll be hash partitioned. If they're big enough, they'll go on to more and more nodes in the cluster. So you might still get some smaller ones which are just on one node, others that are on 3 nodes, others that are on 7 nodes. On top of this, you've got the master node, which because it aggregates most of the results and does lots of hard work, the system is set up so that it doesn't store data on the master node unless your system is very large. So I think the breakpoint is about 2 terabytes, which they change the rules, so some data can go on the primary node, on the master node, I should say. So you can see there's a lot of variables in play, and depending on how things grow, it's quite likely to end up out of balance. So if we go to the next slide, you'll see an example of what it might look like after doing one of these redistributions. So we've got the red columns in the graph illustrating what it looks like after the redistribution. And you can see it's still not perfectly distributed, which is quite common because you've got some big objects that are not able to separate across multiple nodes. It's quite difficult to get it perfectly balanced. Now it can take quite a long time to redistribute some systems. If there's eight nodes and lots of data, we've seen in excess of 12 hours to complete a full rebalance, especially when it hasn't been run for a long time. Now, if you follow DevOps principles, they say do painful things more often so that you get better at them, and you find you get more confident that you can do them in the first place. And so, you know, I think I've encouraged customers to be brave and do this more frequently, get the redistribution done more frequently. But there's also possibilities of reducing the scope of the redistribution. So you do smaller components, or pick the things that are going to have the biggest impact, and then run through the process more frequently.
And I think it's fair to say the more frequently you do these painful things, the less work needs to go on. So the less redistribution there is each time you do it, especially if you keep it frequent.
Yeah, and there's a bunch of tools that we'll talk about later that help you. They'll help you achieve some of these outcomes, and you can actually simulate what it will look like when you've finished the redistribution, to see whether the set of parameters you're feeding the tool set is going to create the desired outcome or not. And it will give you some idea of how long it's going to take, hopefully, as well, once you get some idea of the data movements that are going to be involved. It's worth mentioning actually as well what we've seen in some cases, especially when there's big projects in flight and lots of change. We've seen BW staff keep copies of large objects, large BW objects, large tables, as part of their process to make sure that they've got a sort of a fallback plan, that kind of thing, which is all fine. But if they're left there for too long, then they can take big chunks of the data footprint. They're sort of keeping them to one side and taking up space. Now, because they sort of unload them, they tend to think of them, and they're out of sight, out of mind, and not causing a problem. But if you imagine that this algorithm is taking into consideration all of the components that are making up that data footprint, it's using them in the algorithm, and it's going to distribute those things alongside all the things that are in use. So you could end up with hotspots on certain nodes if you're getting lots of dead data on a particular node. It's also extra time in the actual redistribution because you've still got to move that data whether it's being used or not. So there's, and let's not forget you're backing up that data as well. So I think it's important to make sure that you delete all of those sort of things that you collect along the way during those big process changes. Okay, so we've mentioned a couple of times that there's some tools to help you. So we'll go on to the next slide. So the first thing is, so if you've got some challenges, or you in terms of capacity, or you've decided that you're not going to have a strategy of keeping everything in memory, there's a few ways you can manage that. So the first one we'll talk about is Suite and S4 HANA. So the big move out of HANA is the first thing to talk about, I guess, which is the archive process. So same process has been in and around SAP systems for many years. Typically a sort of a document archive process, and the data still remains available to users, but it just tends to be a bit slower. But now with S4 HANA, and to a degree with Suite, but not in as much coverage, you've got the data aging process, which is using the partitioning methods that Steve introduced in an earlier slide to move data to partitions that are allowed to age and are less likely to be in memory. So there'll be lower priority tables, but it can still be read still within HANA, but less likely to be in memory. Now the application prevents regular users from accessing it, which is good because you've got a challenge there in terms of managing the overall memory usage for that system. You're going to need some headroom to give you the possibility of reading the aged data, but it's quite difficult, I should imagine, for most users to sort of work out what that should be. So you're going to need some good monitoring to help you with that.
Yeah, it's still very new, and we think the tools will catch up and be able to project the amount of data aging, but it isn't doing so at the minute, and that's certainly an area to watch.
Yeah. So next, so BW is slightly different. So if we go again, you've got the archive option, taking it out of HANA, and that tends to happen on the actual BW application itself. It's a standard archiving process, again, been there for many years. Typically these days it's SAP IQ that's the repository for that, what we call cold data. They also refer to NLS, nearline storage. But if we're trying to keep it within the HANA management, then you've got the dynamic tiering option, which is again a SAP IQ, but it's managed by the HANA system. But it is a data migration that you have to do. So there is some work there to work out how to get your data from one store to the next, and also some work in terms of figuring out how to architect how you're going to collect that data within a query. So
how you're going to join it back together.
Yeah, exactly. So it's I think using the word dynamic, stretching the actual a little bit. Anyway, so that's been about for some time, and it's been limited take up on that, I have to say. But they've introduced just recently, reasonably recently anyway, the alternative warm data store, which is the extension nodes, and this builds on the scale out methodology that we talked about just a little earlier, and it provides a mechanism for you to mark objects as warm data store objects, and then they will get moved via the data redistribution algorithm that we discussed earlier to nodes that are specifically for warm data. And those nodes can be more aggressively loaded with data. I think typically you can have a 1-to-1 ratio, 100% of memory for data in one of these nodes. And the idea is that you accept the fact that it's going to be unloading from time to time as it contends for memory, because it's warm data and it's in a lower categorization than your regular.
And this goes all the way back to the first slide, because the way that you denote warm data is in the modeling tools. So it goes all the way back to the first slide where it's about talking to the business with, what is the performance expectation of this report compared to this report, and or data that's aged this much in this report. So it really comes full circle with that talking to the business and getting full buy-in.
And then one step closer to the actual active data is the non-active data concept. This has been about for a long time now. You can mark certain objects as non-active, which just basically means they have a different priority set for unload, and that they get unloaded first if there is contention. So it's useful for the sort of staging areas or working areas of a system. But yes, they're all on the same system. So you don't get the advantage of the segregation that you do with the extension nodes, but at least it sort of it means that not all data is equal within your one container, if you like. So let's move on to the next slide. So there are, as I mentioned, in terms of the management of data across your scale-out cluster, then the data distribution optimizer within the data warehouse foundation is a useful tool to help you assess what things are going to look like before and after the optimizing things. There's more options for optimizing it through this mechanism. And within that suite, there's other products in there that help you with your life cycle of data, help you work out how to delete data. That tool set's useful for people who are using HANA in the native fashion, particularly. But there are also some elements of it that are appropriate to BW as well. Then on the monitoring side, the early watch alerts are going to be useful to you to sort of give you a pointer in the direction of areas that could possibly be optimized.
It's worth mentioning that the early watch reports are just like a fixed point in time. You run it, it tells you exactly how the system was at that point. The problems that were there. You could go back and run the early watch report again, and it'd be quite different.
Yeah.
I mean, the useful thing to mention is the early watch reports are largely based off the SAP HANA mini checks. Yes. So you can download those statements and run them at will, if you like, if you want a more real-time picture.
That's right, yes. Although you do need a bit of expertise to interpret them, do they?
Yeah.
They're quite very techy, indeed, aren't they? So, and still fairly techy, but slightly more usable perhaps. You've got tools like the HANA Cockpit and Studio, which provide you a GUI access, but they are very, very technical tools. Lots of detail in those available for monitoring and understanding your level of optimization. All of those tools we found challenging from time to time when you're looking at a broad estate of systems like we are, managing lots of different customers remotely. They'll be on different versions. Not all of the tool sets will be installed, and nor will they have a desire to install all of the tool sets. So for all of the key metrics that are really, really important for managing systems, we've covered them all in our own tool set called Optic. So capacity planning and performance management in particular, getting to the root cause of problems as quickly as we can remotely is a key important thing for our managed service. So take a look at our website, the Optic website, for this information about this product. So thank you for listening to our webinar. We'd like to help you in any way we can. If you've worked out that you want to do something different with your data, you want to start working out how to do data raging or archiving, then you might want to start with a data assessment to work out what the impact would be if you did decide to archive everything after 7 years, for example, or what would the impact on my memory consumption be if I was to look at a data aging. You can take a look at your data and try and make an assessment so you get a better sizing.
Yeah, if you're already running HANA and you're wondering if it's optimized for stability and performance, we've got a piece of consultancy called the SAP HANA Optimization Mini Pack, where we can answer a lot of those questions for you.
If you're about to install HANA, or you've got another product coming along, you've got some reason for looking at HANA again, and what platform is best for you, we'll help you look at all of the hardware vendors offerings and all of the cloud offerings, and compare them against your needs and help you make the right choice.
Yeah, and once you've got the platform in mind, Centiq can help you with the architecture to make sure the way that HANA's deployed is going to meet your SLAs.
If you've decided that cloud, you want to look at cloud, there's often companies that have got a cloud first philosophy, but not everything fits the cloud well. We can help you assess your workload that's that you're considering for the cloud and make sure that it's a good fit. So if you enjoyed this webinar and you'd like to see one of our others here, there's 3 others that we've done in this series of 4. Hopefully we'll do some more in the future. Thank you for joining us.
Yeah, thank you very much.